Hello students, this video is designed to help you review for the Unit 2 quiz that you'll be taking in class. Let's take a look. The first part of the review was a vocabulary matching exercise. Take a moment to try to see what your answers are, and I will put up the answers in just a few seconds. Here are your correct matches. You should have gotten number 1 being C. You know that number 1 is C because 30, 60, and 90 degrees. In the triangle, this 90 indicates to you that it is going to be a right triangle. For the second one, it says side lengths 2, 2, and 2 centimeters respectively. That tells us that the triangle is equilateral. Equi meaning equal, lateral meaning sides. Speaking specifically about the angle measures here, 60, 60, and 60, this is giving us information that it is equilateral, but specifically that the triangle has 3 equal angles. That's why we're asking for the most specific name here. That most specific name should be same, angular angles. Number 4 should have given you isosceles, and you knew it was isosceles because 2 of these lengths were equivalent or congruent to each other. For number 5, notice that 5, 7, and 9, they're all different from each other, and all different side lengths should make you realize that it is scalene. And number 6, all of the angle measures here were acute except for this one, and if one of the measures of a triangle's angles is obtuse, that makes the entire triangle obtuse. So an obtuse triangle has one obtuse angle, whereas most of the other triangles here, like this one for example, this is an acute triangle because all 3 measures are acute. This one, of course, is a right triangle, as we talked about before, because one of the angles is a right angle. Moving right along to numbers 7, 8, and 9, we're talking about the relationship for each. You could also think of these as theorems. Take a moment to figure those out, and I'll give you the answers in a few seconds. In this first example, it was triangle sum theorem. That THM is an abbreviation for theorem. We know that x plus y plus z, the 3 interior angles of a triangle, are equal to 180. We also know here that if these 2 angles are making up this right angle, that this angle x plus this angle y, those measures are going to be equal to 90 degrees. There should be a degree symbol there. I'm going to put that in a moment. X plus y equals 180 here because these are supplementary angles, also known as linear pairs when there's 2 of them. The angle, which is angle x, plus the angle, which is angle y, is equal to 180 degrees. And just like that, there's my degree measure. Perfect. Moving right along to number 10, it's asking you to find the measures of the missing angles to the diagram below. Justify your answers. In all of these examples, we're going to be using some or one or more of the theorems that we learned about in class. Take a look at the first 3. Take a few moments to pause the video, try these out, and then I'll come back with some answers. All right, here we go with A, B, and C. The isosceles triangle theorem states that the measure of angle x is equal to the measure of angle y. That's this angle down here. And this angle down here, I'll draw that for you here. That's this angle and also this angle. We know that this is an isosceles triangle because of these. We call these hash marks. That indicates when there's one hash mark on each of these lines, that indicates that both of those lines have the same measure. They're congruent. Once we have that information, we say that the triangle sum theorem tells us that 102, which is this angle up here, which we don't know, so we'll use 2 arcs to show that's different. This 102 plus x plus y is equal to 180. Then what we did was we took y, this angle, and we replaced it with x. And we were able to do that because we knew that x was the same as y. Then what we did was a little algebra. We solved for x, and we got x equals 39. Once we got that information, once we knew that this x was 39, this y, of course, must be 39. Taking a look at the isosceles triangle theorem in another way, we know that x plus 7, which is this angle here, must be equal to 55, which is this angle here, because of these markings. Keep in mind, if we didn't have those markings, we would not be able to use the isosceles triangle theorem, because isosceles means that the 2 sides here are going to be congruent. We know they're equal, so we solved this equation. We got x equals 48. Once we got that x is equal to 48, we used the triangle sum theorem, which said that this angle plus this top angle, which we labeled as y, when we added those together, that sum is equal to 180. We did some substitution to say that x is equal to 48, so that goes in here. 48, 7, and 55 added together and subtracted from 180 gives us 70. So there's our unknown. In this third one, we got this little bonus piece of information that this was a right angle. First, we use Isosceles triangle theorem to say, well, since these two sides are congruent, then these two angles must be congruent. Those are called the base angles. We didn't have enough information to solve these for the value of either variable, but we're going to use them later. Triangle sum theorem says that this plus this is equal to 180 degrees. We replaced 9y with x because, well, we know that 9y is the same as x. And then we were able to solve this equation to get x is equal to 45. Once we knew that x was equal to 45, we used something called the transitive property. If 9y is equal to x and x is equal to 45, these two things are the same, which means these two things must be the same. In other words, 9y equals 45. That's what we had here. And then once we wrote that, we said that y was equal to 5. Take a moment to try to do the last two problems here. Pause the video, and then I'll show you the answers in a moment. For the next two problems, we're going to highlight individual triangles. So for example, for exterior angle theorem, we're going to look at this picture, but only this particular triangle. The triangle that starts and goes up to here, the triangle that goes down to here, and the triangle that ends here. So in that particular triangle, we have this angle, which is 47, then this angle, which is 15, and we also have this exterior angle. We know that an exterior angle is formed by an extension of one of the sides of a triangle. And we also know that the sum of the two interior angles is equal to the exterior angle of the non-adjacent interior angle. So that x is equal to 47 and 15. That's 62. The next part we're going to do is the triangle sum theorem, but we're going to do triangle sum theorem to this triangle, because now we have two of the three angles. We have the 90-degree angle that's in this top corner, and we have x, which as we just found was 62. 62 plus 90 plus y is equal to 180, and then we can solve that to say y is equal to 28. So notice we had to use two different methods here to solve this problem, but we were able to do it by separating the diagram into individual triangles. We're going to do the same thing here. Angle addition postulate says that 35 and 18 is 53. We're talking about this angle here because the first triangle I'm going to focus on is this larger right triangle from here to here to here. Notice that that angle is 53. This angle up here, which is a right angle, is 90. So now, in order to find y, we'll just use triangle sum theorem, which says that 53, this angle, plus 90, this angle, plus y, this angle, is equal to 180. A little algebra gives us that y is equal to 37. Now we're going to change gears and focus on this triangle because x is part of an angle in that triangle. So from here to here to here. The angle down here is 18. The angle here is a right angle, that's 90. And the angle here is made up of x and y. That's why we had y plus x. Well, we were fortunate enough to find y before. Y was equal to 37, so that's why we substituted 37. And a little algebra gives us x is equal to 35. All right, we're done with the first page. And then what I'm going to do now is sort of jump through the rest of the pages a little bit and give you a sampling of the correct answers from the other questions in the document. So pause the video, look through your review, and hopefully you'll be able to answer some of these questions, and then unpause and look back for the answers. All right, for the second page, you were asked to take a look at these different diagrams and these different statements, or these different pieces of given information, and asked to write a statement and give a reason. Take a look at the answers here. For each given, write a statement and a reason. This first one, we knew that B was equal to 90, angle B was equal to 90 because of the definition of a right angle. If we're given that it's a right angle, it must be 90 degrees. Here we're given that AB and CD intersect at E. These are intersecting lines, which should make you think of vertical angles. Vertical angles meaning that the two angles on top and bottom are going to be equivalent or congruent, and the two angles that are on the left and right sides are going to be congruent as well. If these two angles are complementary, complementary of course means they are complementary angles. They add up to 90 degrees. For these two, we're saying that line segment AB is congruent to line segment CD. That congruence always is going to indicate that they have the same measures. AB is equal to CD. That's the definition of congruent segments. Triangle ADB is isosceles, which you were able to mark using these hash marks and these arcs for the base angles. And we're also given that DB is the base. You should know that for an isosceles triangle, we could also call this isosceles triangle theorem, that AD is congruent to AB. These two sides are congruent to each other. And also these two angles, angle D and angle B, are congruent to each other. If you're given that angle 1 is congruent to angle 2, we know that angle ABD is congruent to angle DBC because of the definition of a bisector. And we're also able to state that ray, that's ray, BD is a bisector. It splits this larger angle ABC in half. Each of the two halves are equivalent to each other and half of the original. Triangle STP is drawn here with angle 1, angle 2, and angle 3, and we know that those three angles are equal to 180 because of the triangle sum theorem. Go ahead and pause the video again, take a look at that third page, and unpause it in a moment. I'll give you some answers. All right. For number 12, it asks us if the measures of the angles of a triangle are represented by these expressions. The triangle is isosceles. That's our answer, and I'll show you how I got it. We know that the angles of a triangle are all summed to 180 degrees. In other words, when you add all the angles of a triangle, it gives you 180. We combined some like terms to get 12x is equal to 180 and solved for x, giving us 15. Once we got that x value, we substituted it in here. For example, 2 times x, 2 times 15 is equal to 30. 3 times 15 is 45, minus 15 is 30, and you can do the rest of the math by yourself. You can pause it and check it now if you'd like. And you know that when these two angles are 30 degrees each, it's automatically isosceles. It's not a right triangle because neither or none of these angles are 90 degrees. It's not an acute triangle because one of the angles is obtuse. And it's not equiangular for obvious reasons. These are not equivalent. For number 13, you were supposed to find the measures of the missing angles to the diagrams below. We were instructed to find the angle here. That angle is 149, and we know that because this angle is 85, which means that this angle, according to supplementary, must be 95, because 85 and 95 add together to 180. If this is 95, I add that to 54, and I get this angle using the exterior angle theorem. So I used two things here. I used the supplementary angle theorem and the exterior angle theorem. Next, we know that we're given this angle, which is 120, which means that this angle here must be 60 because of supplementary angles. They're in a straight line, so they must add up to 180. If I know this is 60 and I know this is 90, I use the triangle angle sum, or the triangle sum theorem rather, to say 90 and 60 is 150. 150 minus 150 taken away from 180 is 30. If I know that this is 30, I use supplementary again to find this exterior angle, which is, of course, 150. I could have skipped a step by taking this 60 and this 90, adding them together, and that would be equivalent to this angle, that question mark. Of course, that is the exterior angle theorem. I have an equilateral triangle here, and if it's an equilateral triangle, that means it's equiangular, and that means that all the angles are equal to 60. If you're trying to look through this reasoning here, try to follow each and every one of these statements. I'll let you review this by yourself and take a look and make sure that you understand all the individual parts. We know that the base angles of an isosceles triangle are congruent. That's isosceles triangle theorem. We know that triangle sum theorem gives us this 116 because 32, 32, and 116 are equal to 180. We got 148 because of a linear pair or supplementary angles with angle BDA. If this is 32, this must be 148. And we also take the sum of all those angles to make to equal 180 because of the fact that all three angles in a triangle are equal to 180. Here's what you should be getting from this video so far. All of the triangles, all of the problems that you're seeing here are based on a very small amount of theorems. Triangle sum theorem, isosceles triangle theorem, complementary angles, vertical angles. We talked previously about the equilateral triangle theorem. All of these theorems come up over and over again, and all of them are going to help you with your progress. That's the end of the video that I have for you today. Hopefully you found it helpful, and good luck studying.